Hello. It's been a while. Maybe like a week or something, a little bit more than that, maybe. So, yeah, I've been busy with other things. There's a lot of things going on at work, and I've also been playing a lot of Silk Song because I feel like I want to complete that. In order for that to sort of leave my mind when I'm trying to think about ideas for the game. And also I've also been talking with a couple of people about ideas for the game and brainstorming a little bit for trying to get some inspiration, because I feel like I'm at a point where I feel like I want to expand on the sort of ideas for the game, abilities for the player and stuff like that. Because I've been brainstorming a lot, but none of it really seemed like it. Well, it fit, but it was like I want something that fits within the whole puzzle. You can't just go ahead and implement any old idea that you have, because that's gonna be, I think, feel like a game where you don't really have a direction. I don't know. It just feels like if you want to have some sort of ability system or some kind of system in the game, it's gonna fit well with the other pieces, is what I'm trying to say. So I've been thinking a lot about that, but yeah, I've not made a huge amount of progress doing that. And the reason why I think it's important at this point is because it kind of sets the, let's say you have an ability for the player, and it kind of sets the how the enemies are gonna behave. Let's say you have an ability that makes you move extremely fast for a short amount of time, and maybe you're moving upwards or to the left or right or down or something, and that will really, you have to design the monsters based on that. But maybe we could do it like, okay, well, maybe we have like the basic idea, and then moving forward, and then we can sort of come back to previous ideas and redo them when we know more about what kind of abilities we have. Because that's kind of what I have been doing, as like the first area is not really designed with any sort of ability in mind, but then it's sort of like a haze at first. And so then when maybe we're gonna have an ability that we kind of say that, okay, yeah, this is definitely gonna be in or whatever, then we're gonna try and, I guess, add some, like, go through the levels again and redesign in order to sort of in order to get the levels sort of working, how you say it, in order for them to fit better with the sort of abilities that you have, so it feels like it's been thought out and not just randomly created there. So man, I really need to get into this again, because it's been a while. And I'm not sure actually what to actually focus on this time. So last time I think we did some, well, one of the last times, I think it was last time, the one before last time, we did some new monsters and tried out the state machine stuff. So let's see. So we have monsters. Yeah, so we did all these test monsters. So we did 3 monsters quite quickly. Like in one stream we did 3 monsters. So that's pretty nice. I mean, sure, they might not be super advanced or anything, but at least, we got sort of a basic gameplay idea for them all. And it went pretty smooth to actually just, you know, prototype them doing these different things. Now I've not done any sort of graphics for them or anything like that, so what I'm thinking, because the problem is maybe now that since there's no graphics, it's hard to tell them apart. So maybe we'll add like a rectangle or something with different colors, so the color could maybe determine what they look like, basically. So they do have this sort of checkerboard texture, but let's see what we could do actually, because at this point we do have the texture, so we could grab the texture actually. So we could grab the texture component and we can use this texture now. So this texture is a raylib texture, so what we could do is we could draw onto this texture or recreate this texture from something else, from like an image or something. And yeah, so what we could do is, for example, we could make an image and we could do generate image color, and so the width is going to be texture component texture width, height, and the color, I don't know, this is the test monster 1. This one was the one that had the shield. I'm gonna pick the blue color for that. Alright, so there we have our image. Now we're gonna unload image as well, just so we can place this monster now with other things as well. So, and then we're gonna say that this texture, well, first we're gonna now this is the interesting part here. So since we're modifying this, we're modifying the texture component.texture here. What will this be? Will this capture the reference and save it? I'm gonna guess it's going to do that, so you don't have to make a local variable. It's gonna do that implicitly, I'm hoping. I mean, otherwise there's gonna be an error here. But this is gonna be load texture from image. Is this any of these? This could be a texture. Let's just, or I mean, an error. Let's just catch unreachable there, or maybe we can catch. No, let's just catch unreachable. This is like temporary code anyway. All right. Can this be an error? No. Okay. Cool. So, yeah. So we're creating we're grabbing the texture component and we're changing it around, because originally now this has the checkerboard texture. Now we're creating a texture which is like just a blue texture, and we're reapplying it there. So, yeah. Let's see if that can, if that works. Nope. Okay. I mean, yeah, it didn't crash, so and I know one of the monsters is this guy. I'm just gonna check. I know it happens in here. And it's like, if we have an animation, we do this, but we don't, so we initialize the fallback texture. we're adding the texture component here. Okay. So at this point, we should have the texture component. We are generating an image, blah, blah, blah. We're unloading it at the end. We're unloading the original texture at the end. And we're setting this texture to be... I mean, let's just do this, I guess. Just to be sure there's nothing wrong or weird happening with the... that part, the fur things. No, it still has the checkerboard texture there. Okay, there might be something else that I'm kind of missing. So it's this guy. This guy is the one that should be blue. All right. Man, I don't want to have to spend a bunch of time doing this. Why is this not working? This should be just a simple thing. I mean, this, yeah. So how this works with the ECS system is that you get the pointer out, because that's the first thing that you, maybe this is just a local copy or whatever, or we're changing like a local copy and it's not. But this is actually a pointer to the component where it's actually stored. So we are now here, we are modifying the original sort of, or the source of truth, or whatever you want to call it here. And so I'm a bit confused to why this is not working. And this is definitely called here, this function. Maybe there was something in the errors. No. Could not. No error messages. Any warnings? Just the font. Okay. 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 Yeah, I'm confused. I'm sitting there thinking, what could be the issue? We're also like unloading the texture here. Oh wait, we should unload it here. So how, but that doesn't make sense either. Like, how does that work? Because we're, okay, well, let's see. Yeah, it doesn't make sense either way. Like the check, okay, now it works. So apparently when we unload that, it goes back to the checkerboard version. That's weird. Like if I unload it, so that means I'm unloading the newly assigned texture. The old texture is still valid. I mean, it could be, you know, I don't know. This texture is just a struct, like description, I guess, of we have an ID, we have some width and height. It doesn't actually have the data in it. The data is stored somewhere else. So maybe the ID is like, I don't know, man. Whatever. I'm not gonna think about this. So anyway, now we got this guy is blue. So let's make this guy, I guess, red and this yellow or something. I don't want to make. Do I want to make a convenience function for this? Sure, why not? Replace texture with rectangle or something. I don't know, with image, color image. I don't know. It's such a specific thing. So this we need a context. Whoops. And I think that's it. Yeah, and then we need a color. All right. So instead of doing all this, we can do utils, replace texture, color image, and this is blue. All right. And now let's go to test monster 2, and you are gonna be yes, red, I think we said. And we got flying test monster. You're gonna be yellow. All right. Let's just see if it works. Because now I can I can also use them in the game, and also, you know, have them be sort of distinct. Okay, one thing that I probably want to do, like if you see here, when I approach this red one, it's like aggroing, even though it's kind of like out of line of sight. I would like, it kind of feels weird that it would aggro when you're below the ground. Like it's purely based on distance right now. So so how would that work? I think it's probably gonna be more like the line of sight goes, you know, horizontally out like this, and maybe because it's like a ground-based unit, it doesn't make sense that it would aggro if you're below. I don't know, or maybe we want to do some sort of line of sight calculation. I'm not sure actually. Well, maybe we could just start with just having like the horizontal here, but then also it doesn't make sense if there's a wall here. It doesn't make sense to actually have a line of sight going through the wall also. So maybe we should actually just have like a ray trace or something that checks for collision in between, like from maybe from the monster to the player. We're just gonna check if it collides with something else. I mean, that should be easy enough. But the problem is though that I'm not sure. I don't think I have like I mean, I don't have an algorithm for that. So for the collisions, I mean, the collisions right now, you can see here, I'm using a quad tree. Hang on. Let's see here. 1 second. Alright, so I'm using a quad tree here, and you can see kind of here that it's what's happening here is that the blue lines, this is the, or I mean the green line here, the green is like the main, this is the boundary of the entire level here, and then we got the blue line, which is the subdivision of the green rectangle. It's a rectangle, yeah. And so these are rectangles as well. And then you can, and then the next level is red, and then we have the last level here is yellow. I'm not sure if I have like a it can go deeper. Yeah, you can see here there's like a pink as well here, or magenta, or whatever it's called. So there are, and that's the sort of the subdivisions. But it only works. I've only implemented right now for rectangles, basically. So what it does is, what you can do is you can give it a rectangle or a circle. I think maybe, yeah, the circle. I think it makes the circle into a rectangle. But you can provide a rectangle. It will find all of the entities that are colliding with the rectangle. But for array, like a line that goes through, I don't think, like, I have to sort of extend the collision system for that. So that's gonna be a whole thing. Because we can still utilize the quad tree, I think, to do that. I mean, it makes sense. I'm using it for the ground collision and every other collision-based thing. So I should really use it for line of sight as well. Question is though how to do it. So I'm just gonna Google here. Ray collision 2D quad tree, maybe. I mean, I just need like a rectangle, maybe a rectangle. Wait, I'm gonna show the browser here. 1 second. Quad tree, ray collision. I mean, that sounds promising. I'm forced to ask a shameful question. I've built a quad tree structure which contains 2D route triangles. Hey Abbreviator, what's up? Sorry, I didn't see your message. Wait, what time is it? Oh, this was quad tree search. Yeah, the game I enabled the quad tree, sort of, it draws all the quadrants that has like entities in it, you could say, like the smallest subdivisions that's required to cover the entities. And what I'm trying to do here is I'm trying to implement like a line of sight. So my idea is that I would have a ray that is casted from one entity to another entity, like this. So from this entity to this entity, because if I go up to this entity right now, you see now it's not aggroing me, but as soon as I go up here, this guy is like, now is aggroing. And so what I'm thinking is having like a line of sight that goes like this. And so in order to aggro, the line of sight also needs to be not blocked. A conical? I don't know. That's a good question. Conical maybe. I mean, I guess that would make sense. Like if he's like, let's say this guy's facing, like my basic idea was just to have a line between them, and if that's not blocked, then it, it's not visible. But if I jump up here, it's suddenly just gonna be like visible. But it does all make sense if it's facing the other way, that you could sort of sneak up on the enemy to have a cone going in the line, in the direction that is facing as well, or it is facing. Yeah, that makes sense, I guess. Because the way that I was thinking is it would be basically like a circle line of sight. I guess that would be sort of the result of what I was thinking. A circular line of sight, like it's always like around like this, but it's blocked by the. What you would have, but it's, I guess it's kind of efficient because it only needs to check this line here. But a conic, I guess you would. How would that work? Yeah, maybe you check first the line and then see if it's within the cone, or you can check if it's within the cone first, like within these angles or something, and then check for for collision. I think it also makes sense to check distance first. The distance first, then check if it's within the cones, and then check for collision. Right? Does that make sense? Then I think that's it. Does the player also have line of sight? No, I think the player will always like see behind. Will we not be able to see the red box sometimes? Unless it's like hidden in a secret room, you're going to see it. Like, I know there's other games that I'm not gonna mention that kind of has like a light around the player, so there's a lot of darkness around you and you have to be close in order to see what's in front. I've also thought about changing sort of the scale a little bit so you kind of zoom in a little bit, because right now I feel like the player might be too, like everything might be too small. I feel like we want to zoom in maybe a little bit more. But yeah, for the line of sight problem, I think. But even if the player has a line of sight. So are you thinking like, well, it doesn't really matter if it's from the player's perspective or the enemy's perspective, I think. Or does it actually? No, it has to be from the enemy's perspective, because it could be enemies that see farther than the player, so you can get aggroed maybe from a monster that has a better vision than you or something like that. Maybe we can use the information if the player can see the box or the, yeah. I was thinking of that was your idea there, but that will prevent us from having monsters that can I mean, that does work for monsters that have like worse vision than the player, I guess you could say, but not for monsters that have better vision. Also, I feel like that's also like a premature optimization at this point. But it is a point where the collision stuff is the bottleneck right now. The collision detection system is the thing that actually has the most. It's the worst bottleneck right now. But I don't think it's going to be that much of an issue, because we're not going to access the collision system until we know that the player... We're basically checking for distance now anyway for each entity. And then there's going to be a check for the cone. That's just, it's just if angle is between two numbers. So that's not really a thing, a big thing. And then there's... and then there's collision. So it's basically anything within, if the player's within these circles, only then you're gonna check for collision. So I don't think it's gonna be a huge issue. I'd request all four corners of the bounding box of the object. All four corners. Like to each one or to the center of the player? Because I was thinking of having like a cone, like you said, like a cone going out like this. This guy's moving all the time, but a cone going out like this. And so you would approach, it's constantly gonna check within a circle the distance, if the player is within the distance, and then we're also gonna check if the angle is between the player and the box is within the cone. Right? And then check. I mean, if the entity is like small enough, it's not super important. So what would that give us, like, to raycast from all four corners? Center of gravity versus corners, about where the eyes are. Yeah, but yeah, I'm not sure if that's like a huge issue though. Like, if you have a very tall enemy, yeah. We'll see. It might become an issue with some monsters, and then I think we should look at it. But I feel like if we get a basic system where you can check for a cone, distance is already done, but check within a cone, and then also the main thing is checking for collisions in the quad tree. That's what I'm gonna try and figure out. So. So, yeah, that we need anyway. So I'm gonna check this thing here. How do you check if a cone collides with player? So my idea is, okay, should I bring out paint? Well, I have GIMP. Let's see, GIMP. All right, let's do something here, whatever. Right, so let's say we have the monster over here. Okay, and then we have the player over here. Oops. How did... Oh. Disable the... Wait, where's... There. Alright. Whatever. And then we have a line like this. And then we also have like the... let's make this like yellow or something. We have the cone coming out like this. So basically the cone is we have a direction of the monster, so we know if it's left or right. And then we know that so then we're gonna have so we know that the cone, which way the cone is pointing, and the cone is defined. I mean, it basically could be defined by this angle that we're facing here, and then also a number, so that we already have the direction. So we basically just need a number, and the number is gonna be what angle is, this is theta. What angle is, like, how wide is this cone, basically. And so it could be either one here, it could be both, whatever. I guess it's better to have this because we're gonna have like we're gonna have to project two rays, or not rays, but two lines that goes like this. And so what I want to do is basically what we're checking is if this line, like what angle is this line from here, you know, or well, it's gonna be like this, I guess. Well, it's this computer screen, so Y is inverted. But anyway, we're gonna check if this angle is in between these angles. So that's, I think that's the only thing I need to do to check if it's within the cone. Right? So we're just taking the angle here and checking if it's between these angles. A breadth first search. Yeah, so if I go through the steps here, so number 1, distance. So we're basically gonna just take a circle. Let me fix this here. So first we're checking for distance. We're checking if the distance between the entity and the player is within this circle. So basically we're just checking the distance if it's less than this than the radius of this circle. So that is just, so the distance is less than the radius of the circle. Okay. Then we have number 2. So if this is true, we can continue with the checks. If it is false, we exit the checks. Number 2, if it's within this aggro, this is the aggro distance basically. We're gonna check if the line between the player and the entity is within the cone. So line angle in cone. So this is like if the angle theta is between well, and I'm using the same symbol here. Let me use like A. Angle A is between, like, I guess, negative theta in relation to this angle here and theta, basically. That's basically the check here. Yeah. So it's gonna be in between these two. If this is true, we continue on to 3. If it's false, we exit. If it's 3, we will check for if there's like a ground here. We want to check this ray if there's a collision in between. So collision check. Collision check for ray. So the ray between the player and the entity. If there's a collision here, that means there's something blocking the line of sight. So, I mean, let's say there's a wall right here. And even if the player is standing over here, even though we're within the cone, we are in the distance, there's a collision check. There's a collision here, so the monster won't see you there. Well, that's what I'm gonna figure out. I'm not sure how the algorithm is because it's very specific, because I have a quad tree already. So I want to utilize the quad tree in order to find collisions on the path here. So I have a collision. I have a collision check easily for rectangles. Then I can get all the entities that are colliding with a rectangle or a circle. However, for a line, I don't have that. So that's what I'm gonna implement. That's the last puzzle that I need for this to work. Then I can work this out. Like this, I don't have like a ready thing for this either, but this seems easy enough to do. Distance, I do have like a utility function for that. I need to make a utility function for this, but this seems like a simple thing to do. But this part I need to actually look up an algorithm to how to do that, and that's what I'm trying to. That's what I have. Let's see. That's what I have here. So so someone asks here about I built a quad tree structure which contains 2D triangles. Okay, everything would be nice, cool, fast if I knew how to use. Okay, cast a 2D ray from a given point to a given direction. Get the closest triangle position. Right, because also a ray is like, yeah, it gets sort of a point of intersection on the first thing. So it's not really required in my case. Like, I just want to know if there's anything in between. I don't know. I don't need to know if it's the first block or if it's the second block or if it's like where it's like blocking. I just need to know you know, where I just need to know if it's blocking at all. So I know that they kind of do it sometimes with like circles, but I'm not really sure how though. Like how do you determine the size of the circle? Like how do you actually start this out? This has always seemed like a bit magical to me. So let's see what this guy says here, or person here. You need to traverse the quad trees falls. Start at the root node, intersect your array with the root node's bounding box. The root node, like the whole thing, I guess. Intersect your array with the root node's bounding box. Well, it's gonna intersect, so because we're always in the boundary. But I guess, yeah, this is the algorithm. I'm just trying to tie it to my thing. Does it intersect it? If not, yeah. If this is a leaf node, intersect array with all the triangles in the node and return. I mean, I guess Raylib does have like a intersect, like line, a function, a helper function for intersecting a line with a rectangle. So we could use that to work ourselves through this. I was thinking if there was like a super optimized, like already, you know, algorithm that someone worked out with specific to rectangles and quad trees, and you just want to see if it's blocked by anything, you know. We know which node at the start of the line is that, right? So well, yes, I mean, yes, technically we do. If we go to the code of the quad tree, so I have to go to, let's see, let me go here, and we have well, actually let's quad tree. So let's see, we have pages, yeah, we do have a list of entries. Let's see. Also, sorry I missed what you said about your project there, sorry. Yeah, the animation plugin. Oh, nice. Cool. We know the start of the line is, we know the line intersects with the edges of that node. Yes, I guess we do. Yeah. Yeah. I mean, yeah, it's we could. I could use. I think Raylib has a thing for that as well, like checking for intersection of the edges of a rectangle, maybe. Because we're already in the rectangle. We're starting out from within the rectangle, so it knows that it's intersecting inside, but we want to check if it's intersecting outside, I guess. Maybe. And the neighboring node that contains the next pixel and repeat. Well, it's kind of weird because we're going like inside out. Normally in quad tree you would go from outside in, like you would go from the root node, which is the entire thing. It's like the entire, it's containing all of the rectangles, and then you would see, okay, which subdivisions of this. So you would go from level to level. Like if I run the game, and so the green one, if you see here, the green border here marks the first. This is the root node. So this is the, yeah, this contains everything inside. And then the next subdivision, which I call a page. I call each level or each level a page. So the green one is one page, which has the 4 subdivisions. Because it's a quad tree, it's always 4 subdivisions for each page. So the next page is the blue one, which has 4 rectangles here. And then the next page are the red ones. So now we're dividing again. And so like, because the problem is if you start from one of the further in, well, I mean, well, for one we don't, well, yeah, so usually, like, let's say you're doing, saying a rectangle, for example. If you have a rectangle here, you want to check for intersections between these rectangles, or inside this rectangle. What you would do is you want to check, first you check these subdivisions, the blue ones. Okay, which one? They're not colliding with this one, it's not colliding with this one, it's colliding with this one, it's colliding with this one. So we pick these 2, and then we go ahead and check, okay, do we collide with any other rectangles? No, we don't, so no intersections. Up here we do the same thing, but now we're only colliding with this one, so we only need to check further down this now. So we're checking for the red one. Okay, yeah, it's colliding over here. I think the other ones don't actually exist. Like you can see, we're not even painting those. I think they actually don't exist, so we don't even check those because we know that there's nothing there. And then you go further in, so that makes, instead of compared to a brute force, as you would say, check, where you just check the rectangle against every entity in the thing, we're checking against these quadrants, so that makes it like a O log of n or something like that. A brute force would be like O log n squared, I think, if you want to check every entity against each other. But if you just want to check one, I guess it's gonna be like O n. Okay, yeah, I don't know. But anyway, if you want to have, oh, I died. If you want to have a line that goes like this, I would figure you would sort of, I mean, that's what I'm trying to figure out. I'm trying to figure out how to actually do that. Like, how does how do we know if the line, like what rectangles, I guess, to check? I guess we could do the same thing, actually. If we go here again, so we're checking, we want to check this line here, let's say. And so the thing is then, we could just do the same thing. Like, does this line intersect any of these 4 subdivisions? Yes, it's intersecting these two. Okay, we go further down. Is it intersecting this red rectangle? Yes. So let's go further down. I think we could do that, because then we actually do intersect with these guys here. These guys all like sit like a little bit in between here now, but yeah. Yeah. That could actually be it. I think we're just checking. Yeah, I think that should work. Function that takes a line and node, returns a list of nodes that intersect with that line. Yeah. So you would. So I'm gonna. So I already have functions like that for. Let's see. Where's collision? No. Wait, where is that? Right here, for example. Find intersections, body, find intersections rectangle, find intersections circle. So here's the, so I would add another one here, which would be like find intersections line. Right, and then you need to describe the line somehow. So I guess we need like a starting point and an end point maybe. Offset, no. Start, end, yeah. Let's see, line, because you can see here, check collision. So Raylib has check collision, point line, no, rectangle, wait, box. It doesn't have line rectangle? Okay, there's a ray collision. Right, box I think is like 3D. Maybe ray is always 3D. That doesn't really matter maybe though. Quad. Now, yeah, this is vector 3. As you can see, there's like 3D vectors here. So you can split multiple lines and use it recursively. Right, but what I want, the only thing I need here is like a line. At least that's what I'm in my mind. I need a line, checking if a line intersects with a rectangle. I mean, I know I can make my own by, but I don't want to. I can make an algorithm, a naive algorithm maybe, where I check for all the sides in a rectangle. If it's collect, because here you can say check collection lines, and then you can sort of calculate all the lines in the rectangle. You would check against each line separately. But it feels, you know, it feels like maybe there's an algorithm that's better than that, maybe. I don't know. But there was this like get ray collision box, but the ray. What is a ray? It's like a 3D vector with a 3D direction. The box is a 3D. It's a cube, or it's a it's a cuboid, and so it's like a 3D rectangle, and so and then we get a ray collision. Well, I guess we could just set Z to be 0 or something, or 1. I guess. Yeah, and this one also checks for distance. So this one actually checks like which point is the first point of collision as well. I guess it, or where, but yeah, against this collision. Yeah. Or this box, I guess. Point and normal. Yeah. So we get like a direction. We get a get normal of the box, or I guess if it would be a circle, you would get like the normal of that as well. Just the origin of the quad tree node split the line. I'm not sure why would I need to split the line, because my idea is that I would just check if the line intersects I would just use, okay, let's say we have a rectangle here. I'm just gonna define a rectangle here, 64 by 64. Okay, and then I'm gonna make a function that's like, because there was no function in Raylib, unfortunately, for checking a line against a rectangle. So what I'm thinking is I'm just gonna do the rectangle lines, and this is just gonna be, the 4 sides of the rectangle. So each one is gonna have like a start and an end position. So first we have a like, well, let's do vector 2, and so we're gonna have x and y. So that's the starting point, and then we're gonna do x plus width. So that's the first line. It's the top left to the top right, and then we'll do top right to bottom right, and then bottom right to bottom left. Oops, this is correct. To bottom left, and then bottom left to top left. Back. Okay, so we got all those lines, and then I'm just gonna loop through them, and I'm just gonna use check line, and the first position is, start. Also, I need to have like, well, this is gonna be this. So that's the first line that we check. So that's the line that we're checking with, and then we have rect line So we're gonna have rectline start and rectline end. That's gonna be the rectline. So rectline start, rectline end, and we need some sort of collision point. No, where is that collision point? What? Oh, it's a bool. Oh, it's a vector too. Okay, we don't need that though. Collision point by reference? What? No, okay, yeah, okay, yeah, this is a vector too. But we don't really need that, but whatever. And then this returns a bool, so we would check if this is true, we return true. Otherwise, if we get over here, we return false. That's what research. In my opinion, you first find which blue quads the line goes through, then which red. Yes. Checking segments of the line until you confirm the line goes through no quad. Well, I mean, in my mind, we don't really need to divide the line up in segments because you only need to check, like, because the rectangle is where the rectangle is, so you just need to check if the line intersects with that rectangle, right? You don't really need to split the line. The line could always be the same. You always check against the same line. You don't need to, you know, modify the line to only check. Like, you're effectively dividing it, you could say, you know, abstractly, because you're only checking within the rectangle. Because okay, so what's happening is that, okay, we have this line. So first we're checking for collision with this rectangle, and that's true. So there's a collision with this rectangle and this line here. Actually, also we need to check. Oh yeah, I just realized we also need to check if the line is within the rectangle. It's not gonna collide with any of the sides. So we also need to check if both points are within the rectangle. Actually, you know what? Maybe you could optimize it by just checking if the point is within. If one point is in, another point is out, or if any of the points are in, I guess. If any, yeah, that could be the first check. Like, if any of the points are within the rectangle, that means it collides with the rectangle. And then we're checking the sides. Because both points might be outside, it might be go like this. It's still colliding, but we need to check if it's colliding with the sides, right? And my point is here that if you have even if you have a line that goes through everything here, when you're checking against this red one, you're checking, okay, so we know that it collides with this red one. So the next step is to check for the yellow ones inside, right? But the thing is, we know that these yellow ones are the children of this red one. So we're not going to check for yellow ones over here. We're not going to check for yellow ones over here. We're only checking for yellow ones in this red one. So you don't need to divide. And that's why we're using a quad tree. So the quad tree knows that, okay, we're colliding with this rectangle. So now we know that we only need to check these 4 quadrants of this rectangle. We don't need to check this quadrant or these quadrants. We don't need to check these quadrants. So we're going through the children of this red rectangle, right? Yeah, and each rectangle, so it's recursive, right? So each rectangle that it's intersecting, we're gonna check for each child in that rectangle, we're gonna check if it's colliding with those. So first we're colliding with this blue one, then we're seeing that, okay, we only collide with this red one down here, and also that's the only child as well. So, but anyway, but let's pretend there's more red ones over here, but we're only colliding with this red one, so we only need to check these yellow ones, and yeah, and so forth. So you don't need to divide the line, I don't think. You just need to check for collisions in the rectangles and then go further down into that node and or branch, or yeah, into the children of this node here. Does that make sense? So let's see. What I need to do is, so we have this rectangle. I also want to check. So if check collision point rect. So we have the point is the, let's just do start with this rectangle. If this is true, we return true. If we're colliding with the end, we also return true. Otherwise, we need to check each line. So we're making all the lines, and then we're looping through each one, and we're checking for if there's a collision on any of the lines. If that's not true, we're not colliding with any of the points, so we're not inside the rectangle, we're outside, and we don't collide with any of the lines. That means we have to be outside. I understand what you mean, but I couldn't communicate with my what value messages and has. If you catch me streaming, just ping me in a translate. Okay, cool. Yeah, because the way I'm thinking about it, I'm pretty sure, but I might be missing something. Well, I guess we'll see. Let me do that. Okay, so we need that math function we actually need in the collision system. Quad tree. Oops. So let's just make this here. We need like check collision line rec. So here's the rectangle. It's weird how they call it rec, you know, REC. I usually, when you have the short name of a rectangle, I usually call it rect. But Raylib actually calls it rec, which throws me off every time. Okay. Oh yeah, you don't even have Raylib in here, but that doesn't matter. We can just import it. Okay, so now we have this function here. I'm pretty sure this should work, except we don't could define a constant rectangle. But now we have a rectangle. We also need a line as well. So let's have the line first. I'll just do this so that we don't have to do those. I don't know what's faster actually, maybe it doesn't matter. Oh yeah, there we go. It's not used though, but it doesn't matter. Okay. Yeah, so now we have this. It was a way of checking which quads of a rectangle line goes through to facilitate recursion without checking the edges of each quad. Which chords of a rectangle a line goes through to facilitate the recursion without checking edges of each chord? Okay, but let's see if I can make sense. Oh, wait, what's happening? If I can understand, probably here. No, it's I want to see, because I'm thinking about it in one way. Well, it might be an optimization that you're talking about. Yeah, but I want to understand it. So, checking which chords of the rectangle line goes through to facilitate recursion without checking. So I'm like, because I'm not sure if there's like a misunderstanding of how I'm thinking about the problem. Right. Let's see, image. Okay. All right. So, okay. First step, we have a line. Now it's like 45 degrees. Can I make it? Yes. It's like almost perfect there. So first step is to check for collisions on the blue rectangles. So we can see that we are colliding with this blue one and then this blue one, right? Because, yeah, we're inside both of those and outside as well. So we're inside both of those. That should be an easy check. Yeah, so the function that I just did. Well, I can show you visually here. So what I did was, let's take this rectangle here, for example. So the first check that I'm doing is I'm checking if any of the points, the starting point and the end point here, are they inside the rectangle, or either of them inside? Because you can have a line that's totally inside, then it's still colliding with the rectangle. You can, so this one collides. You can have 1 point inside, 1 point outside, but it still collides because 1 point is inside. It's only the case if you have both outside, then there might not be a collision. If you have any of the points inside, you have a collision. If you have 2 points outside, you could have a line like this. It still collides, but you have to check now. You have to check. So what I'm doing is I'm checking these 4 lines if they collide with this line. So I'm doing both. First, I'm doing the easy check of checking if either of the points are inside the rectangle. That's a very easy check. And then I'm checking for if none of the points are inside, I'm checking the sides, all the 4 sides of the rectangle. Or, you know, the first one that's colliding or intersecting. Right? So, because if I only checked all the sides, then this one actually wouldn't have matched. So you have to check also if both points are inside. Yeah, remember now, I'm only checking against this blue rectangle here. It's only for the lower left blue rectangle right now. And then I have to do the same thing for every other blue rectangle. So I'm determining if I'm colliding with only this, or if I'm colliding with this blue rectangle here. So and then I'm repeating the process for everyone. And if we're colliding, then we go down to the children of that blue rectangle. So we're going down to this red one here, and we're doing the same checks again. And since you know we have a starting point here and the point here, you're checking, okay, it's inside. This one is inside, so we are colliding. Yeah, explain, please. I'm very curious. Because, you know, of course, I've probably missed something obvious here, so. I mean, I'm pretty much done. You know, then you just, what you do is you just keep going down. So, let's say we're colliding with this blue one. Then we're gonna check for the children of the blue one, which we know are this red one. This red one is the only child in the blue one right now. And so we're gonna do the same check for this red one. And we're inside here. So with this point, so we know that we're colliding with this red one. So we don't need to do any other check for this red rectangle. So now we can go down in this red rectangle, and since there's no children here, then we're done basically. Well, the only child is this entity. So we're checking against this entity's rectangle as well. And we can see that we are colliding with this entity as well. So now we have this entity as one of the intersections. When you're checking which red lines, do you use the same line equations? Yes. We're using the exact same. I mean, the red one is also a rectangle, so we're just using the same algorithm for checking if the line intersects with, or if the line is colliding with a rectangle, the red rectangle as well. But then when we're doing the check, we're only concerned with this red rectangle here separately. Because it's the only child of this blue, which we've discovered also collides before. So it's only checking the children of the rectangles that you collide with. That's how like quad tree is like optimizing the. You only need to check the children of the collision of the colliding rectangles. You don't need to check the rectangles up here, ever. I think you need more objects how you cannot only check the two ending positions. Well, I'm not only checking the two ending positions, I'm also, this case here, like this line, I'm checking if this point, if this line is collide, where the check is if the lower left blue rectangle is colliding with this line, right? We're checking if the starting end positions are in the rectangle. But they're both not. So what do we do then? Well, now we need to check if the line here is intersecting with any of the sides of this rectangle. And if they are, then then we know the line is colliding with the rectangle. Yes. I check against the edges if none of the points are in the rectangle. Yeah. Because it's easier to check if a point is in the rectangle. And also, you have to cover this case. Because if I only check the lines, if I only checked if we're intersecting any of the sides of the rectangle, then this one would actually not intersect with the sides. This one would say, okay, you're not colliding, but we clearly are colliding because we are in the rectangle. So we actually have to check if both points are inside. But it's enough to check if one is inside. So if either is inside, we know it's colliding. My idea was like so because I didn't want to check against every edge of every rectangle. Right? Okay. Right, refer origin of the screen. So this middle, this one here, oops, let me make that like red or something. So this is O. Yeah. All right. So okay, let me remove the other ones here, just to make it okay. Okay, so yeah, here's the, so let's make this one, I guess we can make this red for the start, S, and then this one, I don't know, maybe yellow for end E. Okay. If I'm looking at start end, I thought I could find the point where this line intersects with the blue line. Okay, so you're thinking about this point here. Looking at start, end, and O, I can determine the point of intersection. Okay. Yeah, so this one is, I'm not sure what to call it. I guess line crossing with O or something, low. Stream has paused 4 times. What? It says dropped frame 0. It lasts about 10 seconds. Huh. Strange. I've also optimized the bitrate because Twitch complained about the bitrate being too high before, so I lowered it to 6000, which is like the maximum on Twitch. So that's strange that it would be so. I mean, it paused. I'll look it back. Let's see. When did it happen last? Oh, you're refreshing now. 125. Okay, is it working? Oh, ads. Okay, yeah. Yeah. There's ads when you first like go in to the stream. Well, basically avoided checking against all 16 ledges of the blues. Okay. I'm trying to think of a counter example, because let's say if you have a line that goes like this. So this is kind of the maximum, I would say. Like it's intersecting 3. You can't have it all 4 unless you're like intersecting at the midpoint. If you're intersecting like the origin, that's sort of like I guess the weak point of the quad tree is like you have to check a lot of I guess yeah, you have to check like all the blue quadrants. But if you have a line like this is gonna intersect all these 3 here. Let's see. So start and so you're saying this, that we have a line like this, which is LE or LOE, which is in this quad up here. Oh, I see. Okay. Well, I understand, but I still don't see it. Let me go through this. So, yeah, start into this is a 1 quad, and this into this is another quad. However, you can still use the same line, because you're not really, when you're comparing. Let's start from the beginning, okay? Let's start from the beginning. So first we have this, well, we have the quad tree, we have the line, we have all these quadrants and all the subdivisions and everything. All right, so we have this line here. Now we have to check if it's colliding with these 4 rectangles, right? But we're not checking the children right now. We're only checking the blue rectangles. So we're doing 4 checks against the blue ones, right? And the ones that are colliding, we go into those rectangles and grabbing the children of those. In this case, we have 1 red rectangle in this one here, and we have 1 red rectangle in this one down here. So we're only concerned with checking against those 2. We're not checking anything up here. This red rectangle is never checked at all, and not the yellow ones either. So this red rectangle we don't concern ourselves with. Yeah, so I don't think we need to divide the line. It's like the line is basically, how you could say it abstractly, is like if you compare the line to this blue one, the lower left blue one, the line is actually doesn't really exist outside. Like the whole universe is only this blue rectangle and this line. So it doesn't really matter how long the line is, because we're just checking against this rectangle. And so the thing is, like, if you're checking against this line here, you still, even if you divide, you still need to do the same checks. Like it doesn't matter how long the line is if it goes like past this one here, is what I'm trying to say, I think. I wanted to avoid, like, dividing line into segments. I wanted to avoid checking if a line intersects with a rectangle. Okay. Yeah, you would have to explain this sometime, because I'm lost to be honest. Like why I'm trying to explain how my algorithm works is because I'm trying to, because it feels like there's some kind of missing information that might, you know, lead to the same result. I'm not sure. Yeah, no problem. I mean, I'm very curious to your solution there. I just feel like if I explain how my algorithm works, maybe it solves your problem. But I don't know. Maybe because it feels to me it feels like dividing the line into segments doesn't really do anything. Or at least I don't understand how it would help. But you would have to show me sometime. So no problem. Like it's me not understanding the idea here. So that's all on me. But anyway, okay, let's just leave that alone here. But because I'm pretty sure if I just do it how I was thinking, we would have a working solution. I'm pretty sure. Yeah, I mean, I'm kind of seeing what you're getting at. It's just that I have a hard time understanding how it would like reduce, like, or what effects it would have on the algorithm. But I'm pretty sure I'm seeing something, but I'm also missing some things. I can feel it. So anyway, I want to make this here so intersecting line. So this function will now grab all the bodies that are, or all the entities that are intersecting with this line here. And so we need a line, or let's just make a starting point and an end point. Wait, I don't have vector. How do I? What's happening? Okay, let's see. Yeah. It's also like when it's so much easier when you also see it visually. It's like explaining in words can be super hard. Like seeing it. It's also the seeing something in an equation instead of seeing it like geometrically, as we say, you know. Yeah, I think it's called like that, geometric. You know, Euclid, drawing circles and lines on a paper. Okay, so so let's do this. We need a result, yes. We have intersections. All right, so here we're kind of cheating because we are using the the rectangle intersections thing here. Yeah. Now I'm in the weeds of this thing that I've built. Like, this was almost one of the first thing that I built in Zig. Was this quad tree here, and it's yeah. You could probably see maybe some artifacts of it being like one of the first things, and I have to sort of get into so I don't mess anything up here, because it feels like it's kind of, you know, just going in here. Okay, we're calling this function. Result is invalid when this function is called again. There's side effects going on here that is interesting, because I think, yeah, what we're having is we have an intersection result, which is like a thing that is being reused for some reason. I have built it like that. So but we're not checking for intersections on this rectangle. So what we need to do, we need to basically do the same thing as we do for this one, except we're gonna check for a line. So maybe we'll just copy this. Now what you could do in this case, because we're basically want to do the same thing except we're changing the source of the sort of check. What you could do is change this into a union enum, and but because that kind of makes it into an overload function, and then you can keep sort of the same surrounding logic instead of making a whole new function to introduce more things. Although it's, I guess it's more optimized though, and this is the bottleneck, so maybe it's better to do this. I guess I'm gonna call this intersecting line as well. And we have the line, so we have start and we have end. Okay. Yes, so we do the same thing, and then we have intersecting inner, which we also need to copy and redo, I guess. I'll just copy it, whatever. It feels bad, but it's inner, so intersecting line inner. Okay. Yes, this should all be the same. So now we're calling line with start and okay, everything else should be the same. Okay, so now basically instead of checking against the ABB or the rectangle, so here you can see how it works here. So we have a page. Now the page represents, you know, all of the blue rectangles, or all of the yellow rectangles in. Is it all of them everywhere, or is it only? Yeah, it's a tree. It's a tree structure. So it's representing all of the blue. So we're checking against all of the blue, then we're checking against all of the red in the blue that collided. And we're skipping the other ones. So here we're checking, we're intersecting. Here's the check here. So we're checking intersection. We also get like a intersection. I'm not sure what this is actually. This returns, well, okay, depth and axis. All right, so it's checking there. Oops. Okay, so basically what we want to do is we want to check if check. Oh, this is R3. What the hell? Wait, where the why did I get to R3? Okay, let me back. This is the wrong this is the wrong place. I need to go to quad tree. Okay. Hang on. Let me go through the proper steps here. So collision, yeah, intersecting. So yeah, it's because this guy intersecting line. Right, it's because this it thinks that this is an R3, which is not at all true. Right, so we need to oh, I see. If it is okay, it is an R3. I'm kidding. I'm just gonna say unreachable at this point. I'm not gonna worry about implementing the R3 for this. And intersecting. Okay, yeah, I went into the wrong implementation. So here's that. So I'm gonna say line here. Go back. Now we're in the R3 again. Okay, let's just go to the quad tree and go for intersecting. Here's that one. All right, now we do the same thing. I mean, the R3 is very similar to the quad tree, so that's why I was like confused there. All right. I mean, yeah, the quad tree, they're both trees. They both have pages as I've designed it and nodes and yeah. So intersecting for page. So maybe I should make it a union enum. Because there's so many functions that I need to copy. Yeah, whatever, let's just copy. I know it's bad, but whatever. Intersecting line. Alright. Yeah, so we're not doing this check, what we're doing. So this is where we want to do check collision line rectangle. There we go. We have start and end. And the rectangle is the page ABB to Raylib. And if they don't collide, we will return. There we go. So that's basically the thing we need to change for everything. All right. So now this is line, and this is start and end. There we go. Need to make it same for the orphaned. Line orphaned. Start end. We're going through each one instead of doing this check. We're doing this one. I mean, I guess I could see sort of a generic thing there. We could actually make, maybe even be comp time known, like the check, the type of check we want to do is like comp time known or something like that. You could do that. So then it's sort of it's still optimized. Maybe we also we don't actually need, yeah, and now since we're only checking that the ax, like we don't actually know these things. Well, we might be able to calculate it, but I'm actually just gonna say whatever here. I mean, I guess this is one, maybe. It doesn't matter, we're not gonna use it right now. Anyway, it's like unsupported things. Okay. I guess technically we could still use, no, like if we know the lines collide, we could check, we could get the intersection information using the other algorithm, because that should then work the same way. We could make this into a rectangle and then check, get the information. I'll just add that as a to do. Make start and end into a ABB, and then check and then get intersection information from right. But for now it's not needed, so okay. Also, we don't really need this to be a Rayleigh rectangle. Like this just needs to be like a min. We just need 2 points. Actually, we just need like a min max. However, this does use rectangle, so whatever. Okay, so that was that function. Now this one is done, and this one is done. Now we need to do this one, intersecting entry. And basically same thing here. Start and entry ABB to Raylib. And let's copy this to do. what's the issue? What am I not seeing? There's something weird with the colors here. Is it this? Yeah. Okay, there we go. Let's see, so now you are line here. Line start edge. And you are also a weird color. There we go. Alright. So now we need to make you as well. Intersecting line, quadrants. It's a bunch of different versions of this. Check quadrant, get quadrant check order. All right. Yeah, this is a bit interesting. I remember something about this, about the check order. It's like you have to check in a specific order for some reason. So how? Okay. This is the index that we start with, I think. This is weird. Why am I looping through 4 times and I only do anything if it's equal to I? I could just as well assume or just use check order index, right? What am I missing here? What's happening here? This looks really weird. So we have an inline for that basically means that we're basically generating code. Each of these 4 cases is gonna be copy and pasted here. So basically have 4 copies of this where I is like 0, 1, 2, 3, and we're checking if check order index is either 0, 1, 2, or 3, because we have 4 quadrants, I guess. And if it is, for example, 0, it goes into the 0, 1, and then we have I think this is a constant. Yeah, we're checking like center point in top left. Then we're checking in a specific order here. So we're checking top left, top right, bottom left, bottom right, quadrants, I guess. Yeah, there is a specific reason for this. I'm not gonna change this right now. I'm pretty sure though that we can just remove this. And instead of saying I here, we're gonna do check order index instead. And so this is the same thing, except it's a little bit more efficient. I'm not sure what we're doing actually. Because we're not reassigning. This is a constant, and so yeah, and we're getting a field which is a sort of a description. Yeah, that's the quadrants. Oh, it's a field name for these. I see. Oh, is it something with the? I see. I know what's going on. I know what's going on. Okay. It's because of comp time. It's the comp time. It's a comp time hack, basically. It's like, in order for this to actually be efficient. So it is actually efficient, probably. I don't know. Whatever, I'm not gonna touch it right now. But it looks very, very strange. But this is gonna be line for page, and this is start end. So that's, I think that's the only thing we need to change. Except we have this A, B, B here. If this contains that, we return. Right, because if a quadrant completely contains the rectangle, we don't need to check the other quadrants. I think that's what this is about. So I think the equivalent of this is just checking if the start and end point is inside. Do we have a function for that? Contains. Okay, let's do contains point. Yeah, it's the same thing, except this is like this is only this is the point, right? Shouldn't this also be like equal? Whatever. Like if it's not, I guess it doesn't contain it. Intersects point. All right. This is also kind of a thing we don't really use that often, but it's like a vector comparison. So you can compare vectors against each other like this, and the result will be another vector where x is compared to x, y is compared to y, and so forth individually. And if you want to check if all of them are less than or greater than here, then you can use and reduce, at reduce, and then dot and here to get a bool out instead, which is basically anding each of the results here. And I think there's a vectorization optimization for that as well. However, these are only two size vectors, so you don't really optimize for those, but if you had larger vectors, then it would automatically like optimize it for you. So this should be the same thing there, I think. Let's just go through this. So top left is less than or equal to point. Top left is less than or equal to point. Shouldn't it? Yes, that makes sense. Yeah. And then bottom, so min is less than, max is greater than. Yes, then it's within the rectangle. So now we can say intersects point and start. Then we return, well, no, we need to return if both of them intersects, because then we contain the line. I guess we could Actually, then we do need to contain. We do contain instead. Contains line. Start. Let's do the specialized version here first. Contains line. Contains point. So alright. We do contains point. And actually now this is just the same thing here. Yeah, this feels a bit, you know, unnecessary to have a function for these things, but whatever. Alright. Now this contains, so it's like, it's not including the outer sort of, you know, the shell around it, the lines around it, so it has to be inside the line. So if the point is like on the edge of the rectangle, it's not gonna count, because then it can still collide with other rectangles. So we need to check if it contains the point. If it contains the line, it means it contains both points. Okay. So now it's like contains line instead. Stop it. Okay. I guess we'll keep the same. Well, whatever. Let's do it. Okay. Is that it now? We're not calling you because we're calling this one, I guess. Line start and okay. Intersecting line per page. Now I think we've connected everything now. Alright, now we should have a way to check for line intersections in the quad tree. Where did we go? This one, I think. Yes. Okay. Now, what else is happening here? We have intersecting line. So we're calling intersecting line. Now this looks a bit weird because well, no, actually it doesn't. This is like the intersect line, I think, but we're just gonna do this. I'm never gonna do the R3 because that turned out to be like a disaster. I couldn't actually get it to work properly. It sort of worked, but then it was like very unoptimized. I'm not gonna like support that. Okay, but here's the intersections. We don't get the type because it's the LSP doesn't think about this as a quad tree. But we have these. Then we're checking distance for some reason here. What's going on here? We're checking the distance between the entry and the line that we need to check against. And if the radius... Oh, because this was like a circle algorithm from the start. Like if this is the circle algorithm, right? So first we're checking, what we're doing is we're turning the circle into a rectangle. Like, you know, based on the radius of the circle. And then we're checking for intersections of that rectangle. Then we're checking for all of the matching entries and checking if they are within this circle. And then we append. So if we're comparing to intersecting a rectangle here, we're simply just going through each intersection that we found and using that. So we should do the same thing here. We don't have a condition. Now what is this? Recalculate the intersection based on the circle here. Let's just say, whatever. I'm just gonna do that. Okay, there we go. Now we should have a function there, and we go back to the physics system. We have somewhere intersect something. Here we go. Find intersections line. Here we go. All right. Now you're gonna call line, and we need start and end, and we don't need to make a circle there. There we go. Okay. What's this? Oh. Okay, yeah, okay, so now this, okay, now we need to dive into this thing here. Oh man, I don't even remember why this was important, but I know it is important, but I'm not sure why. Is it something to do with like optimization? I think there was a bug, to be honest. I think there was like a bug that made it weird if I didn't do this. So basically what it is when you're checking for the 4 quadrants, you're checking collision for the 4 quadrants in the quad tree, like in one of the nodes or pages as I call it here. You are determining like an order on what would be the best to start with. So how do we determine this? We get the center and the page center, and then right, so we're checking, okay, yeah, we're checking which center point, we're checking which quadrant of the 4 quadrants in the page the center point of the given rectangle that we want to check collision against, if where that center point is in the 4 quadrants. So we want to start with checking that quadrant. So if you provide a rectangle, we want to check which entities collide with a rectangle. If that rectangle is that has the center point in one of the quadrants, we want to check that quadrant first, because if that quadrant contain the whole rectangle, we don't need to check any of the other quadrants. So it eliminates a lot of checking there. And what we're doing here is so basically just checking if the center is like at, I guess, the top left. Otherwise we're doing top, like bottom right. That's the only, that, okay, that's also weird, like we're basically skipping the other ones. Okay, well, whatever. And if I'm correct, then the first index of this list would have top left as the first one. Yes. And we're doing bottom right last. Okay, well, it's a little optimization trick there. So what would that mean for lines then? I guess does it even matter? I guess it's to avoid like checking all of them unnecessarily. I I guess, yeah, this is kind of weird. I don't think there's like an equivalent here, actually. I'm just going to go through them. I'm just gonna pick one, actually. So let's just pick the first one. Yeah. Yeah, we didn't change the other code, I don't think, too much, so it shouldn't be an issue. Yeah, still works. Okay, well, now we can implement the line of sight thing. Yeah. So how would that work? Let's go. Well, yeah, I guess we can put it here for now. So we have like distance to player and stuff. Let's do like check if. So let's do like is player in line of sight. Okay. And we need a context for the monster. We need now a description of this line of sight. And I'm just gonna start with the simple thing that we talked about, like the cone. So we're gonna have it's gonna use the direction of the monster automatically. So the only thing we need to describe the cone is with the angle that we talked about, like the angle from either right or left, depending on the monster direction. So if the monster is facing right, the angle starts out at 0, and then you simply have an angle defined here which is like, how do you call it, the field of view degrees or radians, but yeah, sure, we just need to like divide it in half. So we'll do bool, and that's it, because we're gonna get the direction. No, we are gonna get the body. Okay, so the three things that we needed to check was first, it is so distance to player within range. Well, okay, this is not part of this algorithm though. Basically, this is like gonna be a separate thing, I guess. But it's probably gonna be a pretty common thing. If you go to the monster in question, it's like monster 2, I believe. So we have a should aggro. No, we don't. Okay. Oh yeah, we don't actually have an aggro. We have should attack. Yeah, so this guy doesn't have an aggro state. We just have like, if you're close enough, it's gonna attack you. So first we're checking if the timer is expired. Okay, so we have a cooldown as well. But we also want to check the distance. And then we're gonna check a line of sight. And with the field of view, it's like, I'm just gonna have a constant for that. If we're not in line of sight, we return false. We need to define a field of view, which is how much angle how much angle is can see. So it's gonna be something with pi. This is 180, 90. I mean, I guess let's just do 45 degrees. Something, I don't know. Okay. So it's 45 degrees, but then you have to remember it's like rotated as well. So we don't need to check the distance. The first thing we need to do here is we need to check is line within cone, and then 2 is line intersecting with blocking stuff. All right. Hello, Chandu16. What's going on? Welcome. Are you a developer? Let's see. So we need a line between the player and the monster. So we're gonna get the player body as well. Player. All right. And so the line is gonna be start. We're starting at, I mean, it doesn't really matter actually where we start. So let's just pick player and then the monster. Yes. You do arena-based allocation. DOD. I'm not sure what DOD means, but yes, sometimes I do arena-based allocation. I've been using it more and more. Because I think when I started out with Zig first, I only used, well, actually at the all the way at the beginning, I actually didn't use allocators at all. But I quickly realized that it wasn't feasible, so then I started to use allocators, but just, you know, the general purpose allocator. But I realized also that, you know, it was too much of a hassle to manually do everything. It was so easy to miss something, so arena based is really nice, but you have to be very careful anyway. You built stuff like servers and stuff, file stores. I built servers, yes. I mean, not super complicated, I guess. I'm like for SIG, I'm mainly focusing on game development right now. There's no multi-threading going on here. File storage? You mean on a server or? I'm not a Gamedev or like works on backend server stuff. Right. Yeah, well, I'm a web developer, you know, by trade, and I want to learn. I want to get into more like game development. Learning non-garbage collected language right now. Yeah, nice. It's it's not easy. Like starting to think about those things. It's like things that you took for granted when you're working in, you know, whatever language that has garbage collection, and then now you're all of a sudden, as soon as you have like a string or whatever or an array, you have to think about allocation. But yeah, you get into some sort of pattern, and the worst part is when you get some sort of seg fault and you don't have no idea where the error is. You do web development and building Kafka. You're building Kafka? I mean, are you a developer for Kafka? Or are you building with Kafka? Okay, so we have a line, and we want to check if the angle. So now we need the angle from the monster to the player. So what would that be? You're writing Kafka with Rust. Do you mean you're using Kafka with Rust, or are you making an actual Kafka clone with Rust, or are you working? Are you part of the Kafka team? Or sorry, I'm trying to understand. In the programming world has made me more autistic than I care to admit sometimes. You have to be very specific about things. I'm just a dev, not part of a team. You can say a Kafka clone. Okay. I understand now. Okay, that's cool. I don't need a team to write Kafka. I mean, I was asking if you're part of the. I'm guessing they have a team that actually develops Kafka. I was asking if Kafka is written in Java. Okay, well, that's more than I knew. I'm not that familiar with it. I've never used it actually. I know what it is, and what it's used for, but I've never gotten into that. Is it? I mean, it sounds like you're saying it's pretty simple because you don't need a team. From what I've heard, Kafka can be very like heavy to use or get into. I'm not even sure what all the features are, to be honest. People are writing game engines. I mean, it's true. I can write Kafka. All right. Yeah, sure. I mean, yeah. You go on. It's a very nice attitude, at least. Game engines are more complicated. Yeah, I don't know. Yeah, I mean, I guess they are. I mean, Kafka is. Yeah, as I said, I'm not even sure what all the features are in Kafka. I just know that whenever someone is like talking about it, it always feels like it's like this kind of heavy thing. But maybe it's more the usage of Kafka, maybe not the actual Kafka engine itself. I don't know. It's like data streaming. Yeah, but that can also be very complicated. I mean, everything can be very complicated if you make it complicated. It has to be efficient, I guess, is the problem. They write research paper. Okay. I just read that and read Java code, write it in Rust. Okay, so you're saying that you're reading sort of the blueprint plus the actual code. Is it open source? Oh, so you're saying you're basically just copying the algorithms and stuff, porting. Yeah. Okay. Yeah, I mean that's cool. I mean, you know, for the first project in a non-garbage collection, I would pick something easier. But yeah, it's ambiguous, ambitious, I would say. But I guess it's a nice learning experience. I do know a lot about distributed systems. Ah, okay, nice. So you are. How long have you worked in? 7 years with C#. Oh, okay. Nice. Well, I hope you learn a lot from it. Sounds cool. I mean, it sounds like it could be used as well if you work on it for long enough, I guess. But you never interested in game development? Game dev is hard. Yes. I mean, it's so much other stuff. It's not the same as web development. It's like totally different. So it's like it's two worlds that meet, but they have basically almost nothing in common. When it's like, you know, the type of programming that you're doing. I'm interested, but it's hard for me and I do not have as much time to learn. Yeah, there's a lot of things to get into, especially if you want to make your own like game engine. So I mean, I think it's also like for me, I like to make things from scratch so I can really understand what's going on. And that's part of the problem because it takes so long to learn everything. Now I've gotten pretty far, but now it's more of a problem of game design more than actual development, maybe. A lot of math. I will learn machine learning, AI math, or 3D math, and ride the AI math. Okay. I mean, sure, if that's what you're interested in. I mean, I'm doing this because I like games. I like to play games. I like to sort of think about how I would make games. So it's more like that thing for me, like a hobby. Oh man, sorry about that. After working, you're dead inside after working in corporate. Are you in the States? Or where do you work? Like the country? No? Okay, Asia. Okay. Yeah, because there's different working cultures. Like where I'm from, it's like not. I get, well, if you compare it to the States, at least, it's not as cutthroaty, I guess you could say. We have a big respect for like work-life balance. No, I'm from Sweden. So yes, Europe. But I mean, if you would like to learn more about game dev, you can hang around here and we can talk about it, because I like to discuss programming stuff and Rust. I've never really gotten into Rust, and I don't think I ever will. But never say never. But I'm sticking with Zig for now, for like manual garbage collected stuff. I want to immigrate there, but oh really? But I do not know all this illegal immigration stuff. Yeah, are you talking about my country or some other country? Because I know there has been a lot of issues lately with like the government and stuff. All of Europe, yeah. There's been, I think that it's like a wave right now of unhappiness of the state of things, I guess. I'm not sure what it comes from, if it's actually true, or like that things are so bad right now, or if it's just a bunch of rumors that's gotten out of hand. Like I don't know. I don't want to turn this into a political thing either. Let's just but yeah, I don't know. It's crazy things happening. Because that could be a thing, like, because I know that there was like a story circling around, and people just assumed one another things, and when I look it up again and again, I'm the one looking things up, actually looking into what actually happened, and then there's like a totally different story, and people just assume, they are affirming their stereotypes, and it's not good. I think it's like, I don't know. I don't know. I don't know what's going on. I don't think anyone knows 100%. Hope everything gets back to normal. Yeah, we'll see. Hopefully it blows over. I'm more worried about what's going on in the States right now. It's like, because it feels like it's I don't know. I just have a weird feeling that it, something bad is gonna happen. I don't know. Another project looking at LLM inference that can run on CPU. Okay. So like a locally run LLM, or like on the CPU? I think you can, isn't that already possible, or I'm misunderstanding? Yeah, it runs local on PC. Well, at least for what is like the image generation stuff, I've done a little bit of that, so that you can actually choose if that will run on CUDA, or which is like the GPU, I think, or if it's gonna run on like the CPU, but then it's like super slow, and it's already possible. They wrote in Python, C++. I just ported Rust. Oh, okay. Oh, it's a project. Oh, okay. So you're, okay, it's a port. All right, cool. Okay, I need to. So if we go back here, so I need to calculate. So what I'm doing is I'm trying to figure out if the player is in line of sight of this monster, and I need to figure out. I have a line from the monster to the player, and then I need to figure out the angle. Actually, I need the angle in the direction of the monster is facing as well. I wish I was smart enough to full PhD full-time research. Yeah, I mean the LLM stuff is like, I don't even want to touch the research. I mean, I don't want to touch the you know, getting into making your own stuff, in your own models and stuff, because I did, you know, I did the very easy part, like the, what is it called, like the convoluted, no, neural networks, you know, stochastic gradient descent, and I did my stuff with that. It took quite a while for me to actually understand what's going on with that. And the what was it called? The backtracking? No, something like it. Yeah, it goes back. It trickles down. You have an error rate. You have a derivative. You have like a yeah. Anyway, that was very hard for me, and so I'm not gonna go deeper into that, because that's not really, you know, productive for me, and it's not super fun either. So it was kind of cool to get it working and get, you know, the number reader thing, but yeah, the math, I mean, I'm talking about, I think it's like convoluted, I can't remember the name, CNN, I think, like neural networks, where you basically have a flat list, no, not a flat list, but you can have several arrays of neurons that are connected to each other. It's like layers, so you can have any number of layers, and you input numbers, but more advanced neural networks could have like a variable inputs, like a variable number of inputs, but I had like a static number of inputs, static number of outputs, static layers in between, and then I made a thing that you could train that network into recognizing. It's like the basic tutorial for LLMs, basically, which is available on like I think Google had something to do, but basically you can make it read numbers that are a specific format, like reading numbers in an image that is like 28 pixels, 28 by 28 pixels. It could read those numbers, but that took me a long time to actually understand the math behind it and get like the intuition of what is actually going on with everything. So if we're going deeper than that, then I'm tapping out. And within that concept is what I said there about stochastic gradient descent. So if you haven't heard of that, then I think that's I guess one of the most basic concepts in LLMs or the neural networks, because that's how you kind of find like the error margin or the error sort of rate. LLM inference doesn't have that much math. LLM inference is how fast we can run the models which is already trained. Okay. Well, yeah, and LLMs, I haven't done anything with that. That's like a whole other sort of model stuff. Okay, so LLM inference, how fast we can run the models which are already trained. I see. Yeah, because as I understand it, like when they say like, I've noticed a pattern. Like when they say like, yeah, it has like 7 billion parameters or whatever, then it's about 7 gigabytes of memory you need. Something like that. It felt like there was a correlation between how much memory you actually need to run it. Okay, I need to draw some stuff here. So okay, so let's see. Let's make this. So let's say we have the players over here and then we have the monster here. So what we do is we have a line from here to here. That's the line. And so, and then we have a direction of the monster. Let's say it's this direction here. And so we have a cone that goes out something like this. And we have a direction which I'm just gonna repeat over here. Okay. So basically what we're trying to do is we're trying to figure out the angle of this guy, this angle here, which I'm gonna call like player theta or something. Okay. And then we have the monster, so this angle here is like max, and here is min, and those are also like defined here. So actually this angle, I mean, okay, well, we could make this line maybe the minimum. So we could, if we subtract, wait, how would this work? No, isn't this the minimum? And that's the maximum. No, that would be this part here. Because kind of what I'm thinking here is like if we're turning these into actual numbers, this would be something like pi over 16 or something like that. You know, there's a bad pi there, but and then this would be like negative pi over 16. Right? But if we were pointing in the other direction, it would be, this would be like pi, this would be like pi plus 16, and then this would be pi plus this, or just pi negative this. Yeah. And it's gonna be like in between, but this is now, this is still larger, right? Yes, that's larger, but now this is actually min, so it's actually reversed. So this, yeah, this just goes over there. Yeah, because 180 is gonna rotate it like that, and this 180 is gonna rotate it like that. So how do we reflect it instead? So it's kind of like we're taking the difference here, which is pi over 16, and then we're, instead of so we're taking, and then we're taking pi and we're doing negative. Yeah. But that's not max anymore, that's min. Okay. Also, it depends. No, this is weird because this crosses like the 0 line. So when we go over here, I guess as long as this angle is like larger than, like if it is, as long as this is positive, we're gonna do negative 2 pi on it, I think. Yeah, to normalize it. So we need a normal. Okay, I don't know if I'm making much sense here, but I'm kind of doing this mostly maybe for myself to be able to understand what I need to do here. Yeah, whatever. Math, yeah. It's always like, sometimes it's like you're trying to, you know, figure everything out, but sometimes it's really hard to get a grasp on what you actually need to do. I find it very easy. I find it easier to draw things out like this. Sometimes it's easy to just imagine in your head like very quickly what to do, but sometimes when it's like more complicated, for me at least, I find that doing things like this helps a lot. Now we're gonna take direction into account as well, but I'm not gonna do that right now. So this is what we're gonna do here. So we have 0 is this angle here. Then we're gonna have, you know, this, and then this. So okay, sure. Let's start there and see what we're doing here. So I need the min angle, or max, or let's start with min because it's smaller. I don't know. This would be, this is just field of view over 2 negative, and this is field of view over 2. That's max angle. All right. Now, I guess if direction is, I guess we also add this. And there we go. And then we wanna, I think we wanna normalize the angle as well. Maybe. Whatever. Let's just not do that. Okay, so what we need to calculate somehow the angle, 2-player angle, which I actually have that angle too. So we're gonna do from the monster to the player. That's the angle of the line. Okay, so we've got that. Now what we need to do is we need to check if the angle is less or equal, I guess, to max angle, and if, well, I guess we will, we'll check if it's outside, if it's more than max, or if it's less than min. But that could, no, let's just try it. If this is true, like if it's outside, right, that means we should return false. So we're not in line of sight. Okay, next step. Now, so we've done this now, if the line is within the cone. Next up is to check if the line is intersecting with the blocking stuff. So we need to now use the physics system and we need to get the intersections. Find intersecting line, which we've recently in this stream implemented. We are going to take start and then we get our intersections. We also want to defer free intersections. All right, that's the garbage collection part, manual memory management. Then we want to loop through these guys, and well, we have the entry, that's the entity. Entry, yes. Then we want to check is collision enabled for, make a convenience function for that. Is collision enabled for entity and the context entity, which is the monster there. Oops. All right, if that is true, we wanna return false, because then we have collided with something in between, which is kind of, it's blocking line of sight. I think also, like, maybe we're gonna have things that are sort of, I guess, transparent. You could sort of say that, yeah, it's still in line of sight. I don't know, but right now we don't have that kind of thing. But if there's nothing blocking, we get down here, so then we are in the cone and we're not blocked, so we are in the line of sight. There we go. All right, cool. Okay, so let's go to the monster, test monster 2, and here we can see now that should attack is now incorporating is player in line of sight as well. So hopefully this should work now, unless it's crashing. Oh, this needs to be floating point number. Expected intersection found, physical intersection. I see. Wait, but why though? How? Why? This is intersection and an entity. This is, why is it returning a rigid body? This doesn't make sense. No, that's the wrong. That's wrong. Yeah, see, the problem here is we have, like, depending on the algorithm you want to use, it's compiling into different types. It's like a comp time based thing, so it's either gonna choose the quad tree or the R tree depending what you choose. Now we have the quad tree selected, so it should make this into a quad tree. Yeah, you can see there's like two different things here. But why? Wait. Okay, I am very... Oh, I see the circle is different. Why is it different? Well, I guess we'll just do this then. That's right. Com time value. What? Why does it need to be comp time? Does it not understand the type? I mean, it knows it's inferring the type down there. It's like a tuple of tuples of vectors. Okay, well, let's do struct. It's a list of 2 vector 2s. Right. All right, here we go. Yeah, it couldn't infer the type there, so I had to specify. All right, so this red one is the thing. So before it aggroed here because we're in sort of the aggro range, but now it's not. But if as soon as I go over here, now it's like, well, it's not aggroing because it doesn't have like an aggro state. But we are no longer in the line of sight. What if I go here? Okay, well, now it's facing that way. There we go. Okay, it seems like it works. I'm surprised. Okay, and it barely, made a dent in the FPS or whatever. It's not that many checks, It would be cool if we could see the line of sight, but it seems to work. We could do the same thing for the test monster 1, and we're just adding, where's that should aggro? No? Do we have aggro? Yes. Set state aggro. Status ended. Wait, what? Oh yeah, so here from walk. Yeah, okay, so we don't have a function for it. So let's add should aggro. So first we're checking if distance to player is less than aggro distance. Then we return false. So if we're far away, we don't aggro, otherwise. So this is the check we had. And now we also want to add player line of sight, field of view. We have to define let's just use the same. Alright, so now the blue one should also utilize the line of sight. Oops. Okay, so the blue one, yeah, basically all the monsters that can aggro should have this functionality. So now it's like, okay, I'm going up here, it's not aggroing, but as soon as I go up here, now it's aggroing me. And he de-aggroed because I went too far there. Or it, I should say it. Okay, weird. Should also aggro. Now it's aggroed. Should also aggro if it's hit by the player, I guess. So if we're hurt and we're walking, we should also set the state to aggro. It feels weird, like, because we should have aggroed it, I think. Because we were in distance and in line of sight, I think. Or maybe if you hurt it from behind. Yeah, if you hurt it from behind. So let's try that. Now. There we go. Yeah. Yeah, that feels way better. Okay. Oh, yeah. Okay. Nice. Why are you not, like, attacking? Because you have, like, a weird behavior. It's like it doesn't really have an aggro state, so it feels kind of weird, that monster. But yeah, that was really nice. Okay, so we made the line of sight thing. Cool. All right. Well, and we made them. So this time we made them like different colors, so now if I place them out in the wild, we can differentiate them from other things. A couple of things that I want to do with the camera and like everything is I want to sort of zoom in a little bit, so the player is a little bit larger, everything is like it's a little bit more zoomed in. Because I feel like if you see, well, basically you're seeing too much, and I want to sort of zoom in a little bit. So, but I'm not sure exactly what would be the right zoom. Also, it's important that these things are gonna be the same, you know, size, pixels, and everything. So. I would have to think a little bit about that. Right now, everything I think is scaled up by 4. Like every pixel you see here are like 4 times, like, you know, the screen native resolution pixel or whatever. So there's gonna be like 4. How do they do it? Like this? No. Think no, it's the camera, that's right. It's like the camera to the initial camera, the zoom is 4. Yeah, these should always be the same, I think. it's weird if we like zoom out, because it doesn't really make sense in like an 8-bit style game to zoom in and out. Let's try making this like ×6. Because the pixels need to be the same size. Otherwise, I think it would look very strange. Okay, here we go. Is that better? Yeah, because now you're not seeing like the whole damn map. Okay. And probably also this, I want to put this in like a I guess maybe like a top bar that's always covering the screen, so that you can always see what's going on in the UI. I think. I mean, it could be like that, could also not be like that as well. I know that I don't want it covering this side though. It looks like it's really in the way a lot of the times. But I really like this zoom in here. Let's figure out I'm gonna disable my scene override. There we go. Yeah, now well, we need to figure out this a little bit more now. Okay, so the sizes of things are a little weird now, but I think I like this way better than how it was before. Because yeah, it's a bit more focused. You're only seeing like what's near you instead of seeing the whole map almost. Yeah, this is way better, I think. This just this change makes it feel so different. And also you can see the pixels better, which is a positive for me. Yeah, so good. All right. Well, okay. I think that's gonna be what I can, have time for today. So, really nice session today. I got a lot of. Well, a lot of things is too much to say maybe, but we got some things done, like the player vision, the line of sight thing was actually really nice to get done, because it just, small details like that makes it feel a lot nicer, and it's gonna be a good thing to have in the future as well, for other features also. Yeah, and the zoom in, I really like that change. It's nice when you actually do a change and it just, oh man, this just feels right now. This feels way better. So that's really nice. I also want to work on the camera to make it, to have like a dynamic sort of camera system, that the camera is sort of bounded by rectangles that you can define in the editor and stuff like that. So I want to work on that also. So there are, a couple of those things left to do. Yeah, I'm gonna end the stream now. I'm just recapping a little bit here, and yeah, but yeah. Have a nice day. Thank you very much for watching and joining me here. Hope I catch you later. So have a nice day and see you. Bye.